Okay, in this video we are going to do more chain rule problems, specifically problems that involve trigonometry or trig functions, and the problems, there's a link in the description. So let's get started. First problem, we have y is equal to sine to the fifth of x. So I find that with trig functions, the location of the exponent kind of confuses some people. So it's helpful initially to rewrite them a little bit. So I'm going to rewrite this as the quantity sine of x to the fifth. So I see a big function, something to the fifth. An inner function is sine of x, so I'm just going to use a chain rule on this thing. So y prime should be 5 times the quantity sine of x to the fourth, and then, so that was basically the power rule, times the derivative of sine of x, which is cosine of x. All right, and that's like as good as it gets. I'm just going to rewrite it using that exponent notation. So 5 sine to the fourth of x cosine of x. Okay, so we don't want to have to rewrite it that way every time, so let's do another one. So we have y equals cosine to the seventh of x, or cosine of x to the seventh, however you want to say it. So I'm going to just use the power rule right away. So y prime is, so it's something to the seventh, so it's going to be 7 cosine to the sixth of x, right? So it's bring down the exponent, subtract 1. Now I need to multiply by the derivative of cosine because I need to use the chain rule on this thing. So that's times negative sine. And then I'm going to rewrite it because it's kind of weird to leave a negative in the middle. That leads to a lot of problems, or mistakes, I guess I should say. So that's how I'd write this answer. All right, let's take a look at one. It's a little more complicated, but not terrible. Y is equal to sine of 5x to the ninth. So I see 3 functions. I see something to the ninth, that's like the biggest outer function, sine of something, and then 5x. So we need to use the chain rule twice on this thing. So first, we're finding the derivative of something to the ninth. So that's going to be 9 times that thing to the eighth. So we have that. Now I need to multiply by the derivative of that thing, and that thing is sine of something. The derivative of sine of something is cosine of that thing. And then I need to multiply by the derivative of the inner function this time, so the derivative of 5x, so times 5. And then I'm going to simplify this, so I end up with y prime is 45 sine of 5x to the eighth cosine of 5x. Okay, let's take a look at another one. So we'll use a different trig function this time. So we have y is equal to tangent cubed of 4x. So tangent's derivative is secant squared, so you end up with like more exponents than maybe you're expecting, but that's okay. You just have to expect it because you know the derivative of tangent. So I see 3 functions, something cubed, tangent of something, and then 4x. So let's first use the power rule. So it's going to be 3 tangent of 4x squared times the derivative of tangent of 4x. So the derivative of tangent of something is secant squared of that thing, and then times the derivative of that thing, so times the derivative of 4x. So there's only 3 functions to begin with, so you're going to take 3 derivatives. So we use the power rule on something to the third, we know the derivative of tangent of something, and then we know the derivative of 4x. So I'm going to simplify this because I don't think you'd want to leave your derivative looking like that with a 3 and a 4. And we end up with this. Okay, let's take a look at another one. So now we have y is equal to secant of 6x squared to the 8th power. So 3 functions again, something to the 8th, secant of something, and then 6x squared. So let's take the derivative. So first, it's going to be 8 secant to the 7th of 6x squared, so that's a power rule, times the derivative of secant of something. The derivative of secant I know is secant of that thing times tan of that thing. So a lot of trig derivatives just kind of like get out of hand because some of the derivatives pick up extra stuff. So after I did the derivative of secant of something, I also had to multiply by the derivative of that thing. The derivative of 6x squared is 12x. So we power ruled, we knew the derivative of secant, and then we know the derivative of 6x squared. So 2 chain rule applications. This, I'm going to simplify. You'll find this happens a lot when you have secants involved, where you can actually combine the secant from the original with the secant from the chain rule derivative. So we get this. So 96x secant to the 8th of 6x squared times tangent of 6x squared. Okay, let's take a look at another one. So this one is going to involve the chain rule and the product rule. So we have y is equal to sine to the 5th of x times cosine to the 6th of x. Okay, so let's do this. So it's a product, so we're going to product rule. So it's first, so sine to the 5th of x, times the derivative of cosine to the 6th. So it's something to the 6th, so it's going to be 6 times that thing to the 5th, times the derivative of that thing. The derivative of cosine is negative sine. So I have this, plus, because we're using the product rule, the second, which is cosine to the 6th, and times the derivative of the first. So it's something to the 5th, and then we need the derivative sign. So the derivative of something to the 5th is 5 times that thing to the 4th, times the derivative of that thing. The derivative of sine is cosine. And then what I'm going to do is I'm going to just rewrite this, kind of collect like terms, I guess. Carry out the multiplication, simplify. I don't know the right word for that. I mean, I probably do know the right word for that, but I'm not using it. Okay, so I get this. And then the only reason I did that was so I could make the factoring a little clearer. I'd probably just go from the previous step to the final step if I were doing this on my own. So I'm going to take out a sine to the 4th from both. And I can take out a cosine to the 5th from both. And then what are we left with? Okay, so we're left with negative 6, and then sine squared, and then plus 5, and then cosine squared. So I probably should have mentioned this before. If you have a CAS calculator or using a CAS program on a computer or on the internet, it often simplifies trig derivatives in different ways. Like it'll use trig identities, or for example, the TI Inspire CAS doesn't really like to have secants and tangents in its answers, so it'll always change them to 1 over cosine and sine over cosine. So the answers that a calculator gives you look different. So there's a lot of ways you can check. One is you can type in your answer, press enter, and just see how the calculator changes it, and see if it matches what the calculator claims the derivative should be. You could graph your answer and the derivative. You can evaluate them at a bunch of points. Those are all things that I'll do from time to time just to check my answer. This is an example. When I checked this on my calculator, it came up very different from what I had gotten, but it was equivalent. All right, let's move on to another problem. So y is equal to secant of x to the 8th times tangent of x to the 16th. So that's another product rule, and it's going to be kind of like long, not like hard long, but like it's going to fill this line. All right, here we go. So first, secant to the 8th, derivative of the second. So it's going to be 16 tangent to the 15th times the derivative of tangent, which is secant squared. Okay, plus second, which is tangent to the 16th, times derivative of the first. So the derivative of the first is going to be 8 secant to the 7th of x times the derivative of secant, which is secant tan. Okay, so what I'm going to do is I'm just going to simplify this, and I'm actually just going to like bounce to the simplification that I did ahead of time. So that line simplifies to this. And then this I'm just going to factor, because I really believe you should factor these when you can, because we're always looking for the zeros and where it's positive and negative and all that. If you don't have it in factored form, you can't see that. So I'm going to take out an 8, a secant to the 8th. You always go with the lowest exponent when there's two things, and then a tangent to the 15th. And then we are left with the quantity 2 secant squared, and then plus tan squared. This is another example. When I checked this on my calculator, the answer the calculator gave looked nothing like this, but they were equivalent. So definitely right, but definitely it gives you pause when you go to check these things and you have to think, did I do this entirely wrong? All right, let's look at another one, which is kind of different, and there's almost no reason you would run into this problem like in an application other than applying the chain rule, which is what we're trying to do here. So we have y is equal to the sine of the cosine of the tangent of the secant of x. And we're just going to take the derivative of this thing. So this is a really good chain rule problem. So y prime is going to be, so we have sine of something. The derivative of sine of something is cosine of that thing. So what's that thing? It's all of this stuff. Cosine of tangent of secant of x. Okay, times the derivative of this thing. So we need to take the derivative of cosine of tangent of secant of x. So the derivative of cosine of something is negative sine of that thing. And that thing is tangent of secant of x. I feel like the color coding makes this a lot easier. If you're one of those people who carries around a lot of colored pencils with you, it might be a good idea. So now we need to multiply by the derivative of this thing. So first it was sine of something, so that gave us cosine of that thing times the derivative of the thing. That was cosine of something, so the derivative of cosine is negative sine of something. Now we need the derivative of that thing. That thing is tangent of something. The derivative of tangent is secant squared of that thing. That thing is secant of x times the derivative of that thing, and we just said it was secant, so the derivative of secant is secant x tan x. And then the weirdest thing is this doesn't simplify at all. This is as good as it's going to get. Okay, so I'm going to stop there. I hope you found this helpful, and good luck.